Well, thank you for the introduction, Paul. I think you've set it up very well in that we've always been interested in an architecture that's in service of society and tackling the current problems that face society at any one time. And certainly transport and movement was a key issue in the past. But now, as we've been hearing all too frequently, every time I open The Guardian, there's another article on the environment. And of course, with the UN conference going on this week, we made very well aware of the real challenges that now face us. So I entitled this talk Zero. Hopefully it's not zero content, but it's about heading towards a different type of architecture solution. So just a few facts just to get us going. I'm going to talk about net zero carbon and net zero energy. And that's the big issue facing us as architects designing buildings. But it's one of many issues facing society at large. And I think as soon as we think of the planet as a living organism, so that everything we do within it may spoil its balance, then we may come to love the kind of environment we work within and live within and respect it. Because there's many issues beyond carbon and energy. And currently we're working with Professor Johan Rostrom from the Stockholm Institute of Resiliency on a couple of projects. And, you know, climate change is one of 9 planetary boundaries that they've mapped. And arguably, you could say there's a 10th, which is agriculture and soil. But there's everything from the acidification of the seas to plastic pollution to loss of biodiversity and so on. And so these are all stresses that the planet faces. I mean, we're all architects, so we like doing things visually. So just a few visual cues before I get onto some facts to set up the story. So this is there's some great maps, and they're all freely available from Sheffield University, that map different statistics. So this is the world as we know it, as a kind of Cartesian mapping of a three-dimensional object onto a flat field based on the area of landmass. But if you were to think of the world instead as wealth, then what you'll see is the wealth sits primarily per capita on the West, currently. If you look at world population against that wealth, you can see how it's very unfairly distributed currently. And that sets up a kind of growing issue. So carbon emissions now are almost balanced in 4 times in excess of what we can actually cope with across the whole planet. So you can see, I mean, the US, the UK, Europe are all massively emitting too much carbon. But of course, in Indonesia, China, it's already caught up. And the terrifying thing is if you actually look at the last decade and a half of growth of carbon emissions, I mean, what you see is there's a massive increase with the growth in China and India. So if you then plot that against time, so the planet's been around for 4 billion years. So 4 billion years, well, unless you're a billionaire, is a difficult thing to comprehend. So if you map it out in the space of a year, so if a year was 4 billion years, that means that mankind has only been on the planet for 15 minutes before midnight. And in fact, recorded history is only 30 seconds before midnight. And the Industrial Revolution is 1 second before midnight, so 1 second of a year. So within probably a third of a second, so a blink of an eye, we've managed to create this sort of environment on the planet. So actually our impact is massive, and that probably frames the challenge that we now face. So in the middle of the 21st century, the UN expects that population will increase by 1/3, but all of that is within cities. So it actually means that we will double the population of cities by 2050. So that means we're duplicating our entire urban infrastructure, every railway station, every airport, every city. So you can all look around and think, well, great, there's going to be a lot of work for architects, which is true, but clearly we can't go on designing and creating cities the way we currently are. So 60 years, which is only 2 generations, the UN predicts that we will build approximately 230 billion square meters of building. So again, billions are a difficult thing to comprehend. So that's the equivalent of building every building in Japan every year for 60 years. Or another way of looking at it is a new New York once a month every year for 60 years. So the scale of what we are now doing kind of dwarfs what's gone on over the last 200 years or so through the Industrial Revolution. But the good news is that 80% of GDP is actually generated in cities. So in other words, there's the wealth there that we can actually use and harness to do things in a different way. So in my mind, we've got to increase productivity and efficiency, and that's about innovative thinking, and in particular, ingenuity. So there's this old kind of formula put together as a sort of very simplistic way of explaining the challenge that we have, which is I equals PAT. So in other words, population is growing, affluence is growing, so you multiply the two together, and that's the problem that you have to solve. And there's, you can talk about technology balancing out and coming up with new solutions. But in my mind, the E is very important, which is ingenuity, because it's not about actually what you may have to add and the science you have to bring in. Sometimes, and what I want to talk about, is actually what you can take out and do more with less. So we've been hearing plenty this week about the UN and their concerns of the future of the environment, and they've laid out very specifically that the only future is to get to a net zero carbon for all of new buildings by 2030. So we, with a number of architects, have signed a pledge in the UK, there's one in the US, and yesterday in Brussels we signed the World GBC Net Zero Carbon 2030 commitment. So we as a company are committing that all of our built work will be carbon ready neutral by 2030, 100%. So that's quite an undertaking, and to do that, you've got to start now. And so I'm going to talk as well about some of our current projects that are already achieving that. So buildings account for 51% of electrical consumption, 32% of final energy use. But the interesting thing is the split. So the split is, of that 32%, 8% is commercial buildings, and actually the biggest challenge is residential at 24%, so 3 times the energy consumption of commercial buildings. So let's just think about design evolution first of all. So I'm going to talk about housing. So in many ways, house production started to rapidly increase at the end of the 1800s. And in the Midwest, the balloon frame was invented, which allowed for a kind of almost a sort of start of a prefabrication or a faster construction of house building. 36 years later, gypsum panels allowed for the interior lining to get kind of prefabricated and nailed on rather than plaster and lath. 34 years later, the nail gun was brought in. So instead of hammering nails into those sheetrock gypsum panels onto the wall, it was kind of automated, so the frame could be put up a bit quicker and the plasterboard put on a bit quicker. 1970s, a more sophisticated way of controlling the environment through the use of gas central heating. So there's the kind of evolution of 90 years of the built environment in house design. Now compare and contrast that to aviation. So 1901, Gustav Whitehead actually was the first pioneer of propelled flight with a few hundred meters of the very first flight in Connecticut. 15 years saw the fast monoplane. 24 years saw the first transatlantic passenger jet, which was the de Havilland Comet 1. Admittedly, it had a few little hiccups. 1969, Apollo 11 flew to the lunar surface, landed, and returned. So that's 70 years of progress. And when people ask me about aviation and the challenges of the 2% or 2.5% that aviation contributes against the 32% that we have to challenge with on the built environment, I strongly suspect the aviation industry will get to a solution at the speed that they're progressing at rather faster than we will. So I think we've got to really face up to our challenges. So in my talk, I talked about this as being our kind of moonshot moment. And that was because on reflection, 50 years ago this year, of course, was the anniversary of Apollo 11 landing on the moon. So to put that into context, in 1961, when JFK put forward the idea of flying to the moon, landing, and returning safely before the end of the decade, it was actually met with incredulity. People thought it was nigh on impossible, because the first passenger jet had only been flying for 10 years at that point. And the following year, when he addressed a kind of disbelieving American public in Rice, Texas, and gave that famous speech, "We don't do things because they're easy, we do them because we're hard," he galvanized a country. And actually that year, that was my first long flight on the de Havilland Comet 3, and I flew with my mother from Australia to the UK. I know you're all looking, you can't be old enough to have flown at that time, 1962, but I started young. And that took 3 days for 15,000 kilometers. And yet 7 years later, we made the 800,000 kilometer journey to the moon and back. So what it shows is, if you really galvanize thinking and you collaborate and you work as one, we can actually do incredible things as a society. And we are actually investing a lot more now ourselves into research. So we're working on a couple of different housing projects, one of which uses recycled glass into a product that can be printed that's highly efficient, very thermally efficient, inert, so you can actually print buildings. And we demonstrated this about a year ago in the Birmingham design show, construction show. We're also trying to looking at low-cost modular housing systems. This is a house we designed for Puerto Rico, costing $130,000 for a two-bedroom house, $130,000 US. And actually, with that company, we were developing a whole series of different modular buildings using recycled steel components. So I wanted to also keep the conversation broader than just net zero, because it is a broader issue than just net zero. So many years ago, E.O. Wilson wrote his famous book, The Biophilia Hypothesis, and it was about the importance of connection for mankind to nature. And that's something that actually I think percolates through all of our work. And I think it's an essential part, because sustainability and the environment is more than just energy and performance. It's actually about well-being. A few years ago, we won a competition set up by the Bloomberg administration in New York. And as we've seen, housing is one of the key issues that we have to sort. And we were asked to come up with a new typology of sustainable but affordable housing. So it had to be built for the same budget as public housing in New York. And it was a private-public partnership with a developer, Jonathan Rose. And it was one of the last little green slots in the Bronx, in the South Bronx. So we thought it was essential that we kept that green somehow. And in the end, we actually created a built form that actually wrapped around almost like a ziggurat of terraces with different gardens. So we kept all of the green and created, so we didn't lose any of that kind of natural facility and resource in the South Bronx. And it was for a whole series of different income groups, from quite low income groups that had completely subsidized rental housing to different levels of subsidized housing. And we thought it was important they all lived together as one community wrapping around one courtyard, which you can see here. And because it was a narrow slot that we wrapped around with a narrow building, it also allowed us to ensure that every building faced both sides, so we could have cross-ventilation, so we could reduce the kind of energy loading and cooling on the building. It follows the New York Fit Building design guide, so we try and keep people as active as possible when they use the building. And of course, kind of gardens and greenery percolate throughout. So there's a whole series of different kind of program gardens, from orchards to productive gardens. And importantly, all of the rooms look into a kind of central space. So there's a protected, if you like, space for kids to play in, for families to enjoy, to have farmers markets, and so on. And I remember talking to Jonathan Rose when it was all finished, and he said, you know, often when you do a design competition and you win it, it then waters down as you go forwards. And I think this is one of the few times where actually, as we worked on it, actually got richer and more sophisticated. So clearly, when we think about the environment, probably the first thing we think about is the opportunity of solar, and how can we use different resources to minimize our kind of energy footprint. So solar actually has incredible potential. I mean, if you look at how much energy hits the planet, it's 430 quintillion joules of energy. So to put that into perspective, we use 410 quintillion of joules a year. So in other words, every hour, more energy hits the surface of the planet than we use in a year. So it shows the opportunity and resource that's there for our taking. And for us, the kind of research and exploration of an architecture that's informed by the environment actually goes back well over 30 years. And I remember working on this first project back, actually it was 30 years ago this year, so it was 1989, for the Seville World Expo. And we put forward a proposition, and this is Nick's early sketch, that you could actually create a kind of building that used and harnessed the issue and the problem, which was massive, a lot of sun. Seville was the hottest city in Europe, and turn that problem into a solution. So it's probably one of the first buildings that actually used photovoltaics. We had to borrow them from BP at the time. And it had this idea of actually harvesting solar energy from the roof and using this to pump water to cool the building. So actually you can see the age of the building from the video, because this is true VHS playing here. We actually managed to find this clip just recently. But the beauty was that as the sun hit the wall, unlike a brise-soleil, which means you're in shade, it took all the infrared out of the sunlight. So when you went inside the building, it was very bright and light, and yet it was completely cool. And so, the sun was actually cooling the building. And I think the other area that we've often been inspired with in our architecture, in looking for a more economic and efficient solution for the built environment, is nature. And this goes back, when I was a student, I was very inspired by Fry Otto and the Institute of Lightweight Structures and all the work that was done there. And if you get that, I think we've taken on into many of our projects. So when people talk about Eden, they talk about the influence of Buckminster Fuller. But actually, to be honest, Fry Otto is probably an even bigger influence in his work in interconnecting soap bubbles and surfaces. So Eden was one of the Millennium Projects. Wonderful group of people. They didn't have a site and they didn't have any money. But we took it on because it was such an exciting proposition. And the idea of trying to create something very bold and ambitious, but on basically a shoestring. So they didn't have anything like the money to do a very large glass and steel structure. And the site was equally challenging. It was an old quarry coming to the end of its use in Cornwall, one of the China clay quarries. So the challenge here was to convert it into a 21st century botanical garden that demonstrated to people visiting it the relationship we have with the planet through plants. No plants, there's no life on the planet. So again, we kind of drew upon work and research we've been doing at the time. And we were very interested in a material which was fairly new then, ETFE foil, ethylene tetrafluoroethylene, which is a very lightweight polymer. And we came up with this idea of generating the building out of spheres, which of course is the most efficient way of covering the maximum enclosure with the minimum surface area. So it makes it very efficient. And then you take these spheres and effectively, in a computer model, push them into the ground, and that gives you the geometry of Eden. So it meant we had a very lightweight, very efficient structure using the minimum of embodied energy. So it uses around 1% of the energy you would have with a glass and steel building. So 1% of the volume. And each of those pillows spans around 11 meters without any structural intervention. So it meant that the actual weight of the roof, when we calculated it at 800 metric tons, was less than the weight of the air inside the buildings. So again, it's about kind of ultimate efficiency. So harnessing the wind, again, I think this demonstrates how you can do something using natural resource that actually removes things. So this was a project in Melbourne, and the government reference scheme was to basically create a building with lots of plants and equipment on the roof, that would do the ventilation and deal with the heating and so on. And we realized that there was a couple of, there's prevailing winds, that if we designed the roof almost as a series of moguls, it could actually help extract the air from inside the building and also keep the building cool. So actually, the geometry of the roof is the entire building environmental system. So what we did was actually create a completely net zero system. So the roof shape itself provides the entire environmental tempering of the space inside. And something that we followed on a number of projects. This is a project we just completed in Miami for the new Science Museum. And in a way, it draws a lot from landscape as much as it does from building. And we were given a Department of Energy grant to study the building and look at how we could reduce the energy of the building. And so we came up with the idea of using the cooling winds and breezes that come off the bay and actually rethinking how the building worked so that all of the circulation space was actually outdoors, because most of the year it's actually a very pleasant environment, and if you can cool it with breezes flowing through the building, you can think of it as really as streets. So all of the horizontal and vertical circulation happens in this open street that draws the wind off the bay through it and cools it. And it also has the advantage of also people using the museum are continually connected to the outside environment. So they're connected to the bay beyond. Even the aquarium is actually open to the environment above. So it means that above the building, you enjoy the exhibits and you enjoy the connection to the outside. And then below, I suppose, the tour de force, and this was, I think, inspired probably one night in a bar by a martini glass. But rather than creating a traditional aquarium where you look through a surface and like a giant picture window, we wanted to create the environment of what it would be like to be a diver looking up, where you see nothing but the expanse of the ocean and the fish swimming above. So because it's a conical form, you don't see the surface area. You only see the water above. So I want to finish off with 3 projects that talk about net zero. So as well as achieving 2030 net zero for new buildings, the UN have also stated that we actually need to retrofit our existing building stock by 2050. And actually adaptive reuse is something that we've always believed very strongly in. So one of Nick's earliest buildings, which was the Herman Miller factory that was designed in 1977, it came to the end of its life in 2017 when we built a new facility for Herman Miller and moved them into it. And over the last 2 years, we've actually taken it apart. And the great thing is the building just comes apart as a kit of parts and you can change it. And it's been rebuilt now as the Bath School of Art and Design, which just opened about a month or so ago. So you can see it on the left as a factory, and on the right now is the School of Art and Design. And actually the building lends itself very well because it's fairly loose fit. The services were all kept in certain areas which allowed us to reroute them. So it's very easy to reprogram it. But we also raised the performance of the building to current, or above current standards. So obviously it was designed in the 70s. It's now performing as it should do for the 21st century. But nothing on the building visually has changed. So it all looks the same, but the performance has been massively enhanced. And this sort of retrofit is something that we're going to have to do throughout our entire building stock. But I have to say, as a factory, it also makes an amazing creative space for art and design. So far it's been very well received by the students. So it's had a 40-year life producing office furniture, Action Office and so on. And hopefully now it'll have an equally long life, if not longer. So it'll do a full century, but now as a School of Art and Design. So net zero carbon was how I started the talk. And I just want to talk about 2 principal projects now. One we're doing for the Arizona State University, and it's their new research center for environmental science. Now, net zero carbon is a complex area, but in very simple terms, these are the kind of hurdles that you have to get over. So first of all, net zero carbon operations is actually not the building itself, it's how it operates. So to achieve and be certified, it has to operate for 12 months at net zero carbon. So we actually design net zero carbon ready buildings, and it relies on a relationship with the end user to then operate it in the correct way. So it's actually got to be a partnership to take it forward. And it requires also a 25% reduction of energy use. So that's the energy use, the intensity of energy of the building, which for a laboratory building is actually quite a challenge because they are very energy intensive. And it requires also 100% renewable energy, but it doesn't have to be generated on-site, it can be generated off-site, which is what we're doing as a mixture at Arizona. And then you have to calculate the total embodied energy of the building and have a reduction in the comparative building, but also there's a maximum embodied energy per square meter. So there's a series of different challenges you have to get over. And so really learning, I guess, from our previous experience of how can you remove things and how can you work with the environment. Now clearly, the southwest desert of Arizona has its challenges to do something as net zero, but it's also a fairly dry and benign environment where you can actually live outdoors if you have enough natural cooling and so on. The site we had was quite interesting and challenging, but the challenges offered opportunity. So there's a canal that actually runs right through the middle of the site, and a light rail that borders the edge of the site. And so rather than seeing those as hurdles, see them as opportunities. So we looked at the massing of the building, carved it up, thought about the circulation, put the circulation in what you might normally think of as an atrium, fairly traditional way, but then lifted the whole building off the ground to allow the ground plane just to sweep through and connect it to the whole campus. And in a way, really drawing on, I guess, a tradition of use of the courtyard in this part of the world and the natural breezes and cooling that you get in all the canyons in Arizona. So the building actually floats off the ground, and all of the public circulation space, just as we did in Miami, is actually external in this outside atrium. So it allows us to just let the canal sweep through as a resource. It allows us to have the landscape sweeping through the building, and it means none of the circulation needs to be air-conditioned or environmentally controlled. And indeed, the entire building has hardly any forced air cooling. It's all through chilled beams. Obviously, the skin itself is all about performance and how it works, and so again, we wanted to create a skin that was self-shading and performing. So it's a very it's like a performative approach to design. And so we developed this approach to the skin, and of course, every facade has to be considered differently because each one performs in a different way. So each surface has a different aspect to it. So every elevation is different because it performs and responds in a different way. So of course it meets LEED platinum, but for the net zero carbon, what we've decided to do is to work with the International Living Future Institute, and those are the standards that we're working to for accreditation of our buildings. And the other important thing is the energy use intensity. So you see here we've achieved 107. So to put that in perspective, most high-end performing laboratories would be around 4 times that, around 400. And a very efficient one would be 300. So the other side of the equation is creating incredibly efficient, high-performance solutions. And part of the energy is generated actually on the building, and the rest is on a dedicated solar plant on the campus. And the president of the campus has an incredible ambition to actually turn the entire Arizona State University campus to net zero. So that's the other great thing here, is also an important aspect, is working with a client that shares the kind of same approach. Another net zero building we're currently working on that will open just more or less this time next year is the Sustainability Pavilion for the World Expo in Dubai. When we were approached to do the competition, there there was a certain degree of incredulity, I think, with our partners, in that when you think of net zero and sustainability in Dubai, it's a bit of an oxymoron. You know, ski slopes in the desert and so on. But actually, one working with the Emiratis, I've realized how forward-looking they are and how ambitious they are for their own country. But also, we thought they were expected to be, it's supposed to be the most visited expo to date, with around 25 million visitors, of which almost 2/3 will be international, which is an unusual kind of proportion. And so the opportunity of demonstrating that you could do net zero, totally sustainable, self-sufficient building in one of the world's harshest environments, if you can do it here, you can do it anywhere, was an incredible opportunity. And the building will also become a permanent institute, researching sustainability and a public kind of institute for Dubai. So it's their first major kind of public institutional building. So it sits at the center line of the whole expo development, of which 70% will remain when it finishes in April 2021 and become, if you like, an extension of Dubai and a kind of innovation center for the city. So we decided if we were doing the competition, we would do it no holds barred, 100% self-sufficient, generating all of its own power, more importantly, generating all of its own water, recycling all of its own water, being completely and utterly self-sufficient in the desert. And hopefully, of course, it's not yet run, but so far, with our engineers, Bureau Happold, we're confident we'll get there. So the first thing you do is use the natural resource that are available. So the building is actually sunk underground. All of the exhibit area is sunk underground because the whole site was being changed in level. So that naturally heavily insulates a lot of the building. And then the remaining 50% of the building sits underneath a very heavily landscaped roof, so it's also insulated. And then it's bounded by Gabion structures and a very heavy thermal insulation. And then floating over all of that is the canopy. But here's the challenge from an engineering perspective. This would be a very high-performing platinum LEED building. So it's a bit like the one we looked at Arizona. It's generating half of its power on-site, half off-site, and entirely 100% renewables. But to be 100% self-sufficient on-site, this is what we had to do. So we had to create a much leaner, more efficient building, and then work out how we could increase the actual generation of power on-site. And it's a similar story with water. So this would be a very efficient building using a lot of recycled water. And what we've had to do is actually go through the entire system, make it much, much more efficient. And then we're generating more or less all of our own water on-site and then recycling that, right down to the level of our 10,000 visitors an hour all breathe out and create humidity. We cool the air, we take the water out from them and recycle it and put it back in the system. So they're expecting around 25 million visitors. I think if we hopefully will get 5 million through the actual building over those 6 months. So not everyone will get a chance to go through it. So we thought it was important that more people could actually just enjoy the building as a whole. And actually the landscape tells an important story. So visitors actually explore the exterior, and we've worked very closely with our friends, the Eden Project, and a very innovative firm in Dubai called Desert Inc., looking at how we can use plants that haven't been used before in external landscape. So it's using plants harvested from the desert that we've experimented and tested so that we can have a landscape that needs very little irrigation. So we can show how you can have an urban xeriscape that needs very little irrigation, yet can be incredibly beautiful. And this is my favorite area, which are the most boring plants. So we've tried to make them exciting, but they're very important because they're called halophytes. So they're one type of plants on the planet that can grow in salt water. So there's a lot of research going on at the moment, actually with Boeing and NASA, with the UAE, on creating biofuels and also food crops, because obviously what the UAE has plenty of is salt water and sand, and so here's the one plant in the world that can grow in that environment. So for those coming to the building, they'll be able to enjoy that landscape, then they'll be able to look down into the courtyard, which is the kind of main entrance into the exhibit. Surrounding the building, as I said, we've got kind of Gabion walls, landscape, so it's very much of the landscape. This, in the long term, will become the entrance, but it's actually, we had to reverse the whole circulation to get more people through. during expo mode. So you will actually enter through the building underneath these, what we refer to as E-trees, which I'll come on to, that provide shade, and then into the courtyard. And then you'll explore an exhibit that we've created with the Eden Project in Think and the Stockholm Institute of Resiliency that's all based around planetary boundaries. And at the very heart of the building, deep below ground, you find the reservoir where all the water's kept. And from there, you can actually look up all the way up through the building to the sky. There's a connection between the sky and the water below. And around the buildings, we were kind of inspired by these dragon blood trees from the southern Omani Peninsula. And they have a waxy leaf that can actually pull water out of the air, but also shade the space below. And so we've developed these E-trees. And the great thing is that actually both these and the roof canopy were all built about 10 minutes away from the site. So these are made of carbon fiber. They're very light. They're quite large. Each of them, they all have solar bifacial solar panels. And inside those, we've actually created this moving mechanism. So what that allows us to do with the very lightweight top is to track the sun. So this is just from a visit last week. We tested the first one. And so throughout the day, all of those 20 E-trees follow the sun throughout the day, so they provide the maximum shading below, but also increases the yield of the solar panels by about 25%. And the canopy itself, I think, is inspired by a gaff tree, providing shade. So although the building is kind of based underground and under landscape, soaring over it is this shading device that not only harvests energy, but also shades below and then directs breezes. And the lovely thing was, last week, being in the courtyard, you get a kind of rush of air running through the space and cooling the space. And we've worked very hard with our engineers, Bureau Happel, to actually halve the weight of steel, and we've used recycled steel, and to keep it as light as we can. So, but it's a large structure, shading the whole building. I'm just using the obligatory, this is a London scale, it's called the double-decker bus, but it gives you a sense of scale of the 71-meter cantilevered structure. So approaching the building, this is the kind of view you'll get. This is it now, well under construction, and we'll be completing early next spring to commission it, ready for opening in October. So I just want to finish off with a bit of work we've been doing. So along with this goal of getting to net zero carbon in our built work, we've been looking at our own operations. And we run a global operation with 8 studios stretching from LA through New York, London, Paris, Dubai, Melbourne, Sydney. So we try to use intelligent systems, try to use video conferencing, but undoubtedly it still means we do a lot of flying. So we've calculated all of our carbon footprint from our communications between the different studios, our different operations within those studios, and we've made a decision as of 2020 to operate as a net zero carbon company. So so I just wanted to kind of use this opportunity to kind of make that public, because it's quite a commitment for us. But I think if we want our clients to join us on this journey of developing and designing a net zero carbon future, then we all have to demonstrate and walk the talk. So we've been hearing from the UN, who have accused the world of fiddling as the world burns down. And I think it's important for us to start this next decade together, working often collaboratively, to actually think of creating, to be the generation that doesn't let things get worse, but to be the generation that completely transforms our planetary architecture and built environment, and to use this decade as our moonshot to get to a sustainable future by 2030. Thank you.
Andrew, thank you so much for getting us off to a challenging, but I think optimistic and constructive start. Because it does strike me that the terms in which environmental change is happening are almost inevitably and understandably sort of catastrophe. The message is the end of the world is nigh. And what your approach is saying that actually there are mitigating things and kind of positive things that we can do to start reversing these trends. As sort of the former UK government chief scientist, Sir David King, is working on ideas, well, can you project things into the atmosphere to start refreezing the Arctic, for example? And I suppose the question architecturally for Grimshaw is there is a sense in which the practice's interest in technology and structure, it's kind of going back to roots, but I suppose there's always been a line of continuity through the work anyway. Is this a sort of, is it a moonshot moment, or is it actually just an enhancement of what you were doing, let's say, at the Eden project?
Yeah. No, you are right. It's a continuation. I think that the difference is being completely focused on, none of us are 100% consistent. And what we're talking about now is actually getting to that consistency. So it's not just, some of the projects achieve this and some achieve that they all achieve a massive performance increase. And I think what I wanted to bring up is it's not about just applying technology, or it's actually about clever thinking. So I think our brains can do a lot of the work, and it's about what we can actually take out. So hence the kind of, the ingenuity part, because rather than sort of throwing technology at it to solve a problem, I think we can actually use our brains to solve it. And, when I was talking about the building on the Southern Cross building, it was happening at a time in Melbourne.
The Melbourne one, yeah.
I mean, it was happening at a time where architects were creating a lot of kind of curvy roofs, but it was kind of shapes for the sake of shapes. So it was using some really sophisticated computational design tools, but just to make bits of abstract sculpture. And in my mind, those tools are there for us to use to create a much higher performing architecture. And in a way, if you do that, actually, I think it has a more inherent beauty to it as well, because it's the way nature works.
I suppose there's an implication. I was thinking as you were showing the way that you synthesize the effect that wind could have on ventilation systems and cooling, that actually you could think about that in the same way in relation to whole chunks of city. I think one of your things in Dubai is showing the way that the air is moving through a whole built environment.
Yeah.
And I wonder whether you, or indeed anyone, is looking at the implications of whole city thinking in relation to wind flows.
Yeah. Well, we've been working on a project for quite a few years in Tirana, where we're looking at remodeling the whole city and actually using what was the main watercourse in the center of the building almost now as a green lung and a resource. So, like many cities, it turned its back on its sort of central river and used it almost as a drain, and actually turning it into a resource. But you're right, actually, we need to think not just at the micro scale of buildings, but actually how cities operate completely because cities use a vast amount of the world's resource. So we've got to create and remodel cities to become much more efficient.
One of the things that I think your talk has raised is this this question of appropriate comparisons between different forms of transport or different forms of energy generation and what is actually doing what. Because as you pointed out, let's say in office buildings, it's not really the buildings that are using up electricity, it's the people inside carrying on with their normal business, and we've all got laptops and there have to be battery sensors, etc., etc., etc. And I wonder whether you ever get the feeling that in a sense that architects or the world of construction becomes a bit of a whipping boy for this, because you can target the building, whereas nobody says how disgraceful it is that, people who employ people in offices actually use electricity.
Yeah. No, you're absolutely right. And if you delve down into detail, there's some very detailed UN reports on energy use. So if you look at residential at 24%, it's not that the buildings, yes, need to be better insulated and better performing, but actually one of the big issues is the massive increase of appliances. A generation ago, everyone didn't have a tumble dryer, 2 dishwashers, a washing machine, 5 televisions, 4 computers, 6 telephones, etc. And so actually the technology that we're all buying and putting in is actually a large part of the electrical consumption and use.
And of course, population increase isn't going to make that problem go away, to put it mildly.
Yeah.
I mean, that's, and in a way, again, it's easier to complain about the energy the carbon implication of cement, rather than tell people to stop having children.
Yep.
I mean, the Chinese tried it with the
Yes.
one-child policy. It's a social disaster, now reversed. But the implication is, as you very succinctly pointed out, that whatever we're doing at the moment, we're going to have to kind of double up, or at least 50% up, which has its own challenges.
And we're only part of the equation, because I mean, deforestation, I think, is currently running at 14 million hectares a year, of which half is recovered, half is lost. So 7 million hectares of forest lost. And that equates to, I lost my mic.
Yeah, I think we've lost the mic for a moment.
Okay. So, I mean, that equates to about twice the area of the Netherlands.
It's okay.
I'll just use this. Great, thank you. So, yeah, so of the 14 million hectares a year that are lost through deforestation, that accounts for 8% of CO2 emissions, so the equivalent of commercial buildings. So deforestation in its own right would be the third biggest polluter after China and the US, if it was a country. So, so the challenge is we can only do so much to fix the built environment, but actually as a society as a whole, we've got to take on all of these challenges.
So it always interests me that this is not a defence, by the way, of aviation, but actually the percentages are pretty small, aren't they, compared with deforestation. And compared, I don't know if you've looked at, I guess you have, but in terms of carbon emissions from transport as a whole, I mean, aviation scarcely features. Merchant shipping, for example, is gigantic, but no one seems to talk much about that.
Yeah, and like all these things, it's not as it's not a simple equation, because actually aviation has massively increased and boosted tourism, and now I think globally 1 in 10 people are employed through tourism, and there was a very interesting article in the New York Times by an environmentalist last week, talking about the number of environmental projects around the world that rely totally on tourism. I mean, Costa Rica couldn't follow its zero carbon approach if it didn't have people flying in there and being there, because it relies, totally on tourists. So it's not as simple as removing, just saying, well, we just don't fly, because that would actually have all sorts of other implications.
Well, it's often given to architects to kind of synthesize, apparently, insuperable contradictions and complexities. Can I conclude this session by asking you a bit about your net zero operationally for the practice, because clearly you will still have to do a certain amount of travel. You still exist in offices which are using electricity, et cetera, Can you give us some clues as to how you offset or do a bit of generation?
Well, I mean, one of the things we've been doing on the offsetting side is working with our friends at Eden, with Tim Smith and his team, which we're going to produce actually a kind of new strategy of creating a number of projects with them that are then replicable on offsetting. I mean, clearly on each studio it requires analysis. We can't always buy and get renewable energy in all of our different locations. So when we can't, we have to add it all up and then do a separate carbon offset for that. Same with flying. The only way of dealing with flying currently is carbon offsetting.
Is this to put it in simple language, is this tree planting, or are there other things as well?
A whole range of things. Because actually, I mean, tree planting is important, because I've talked about deforestation, and we've got to reverse that. But actually, even agriculture and soil is something that's not talked about in a great deal, but it's a massive area. And if you just look at even the production of food and how that's currently done, and the drive for efficiencies there. So it's a range of different projects.
Are you, in the end, optimistic about our chances of being that generation that starts to reverse, or do you think actually that that population growth and kind of the overwhelming scale of the problem will mean that we can fight a good fight, but we're going to have to accept a fairly honourable defeat?
Well, it's a good way of putting it, Paul. I mean, I think architects generally are optimists at heart, and I'm an optimist, but I'm also pragmatic as well. So I think there's two sides to the coin. I've only talked about one side. The other side is that the world will change. And so resiliency and rethinking how buildings operate and rethinking how cities operate in a different environment will inevitably also be our other challenge, which is a whole separate talk. But undoubtedly, we have reached a tipping point where we are going to be in a hotter environment that will increase water levels, that will increase storms and weather and so on. And so along with this approach of trying to create highly efficient buildings in a built environment, we're also going to have to create a much more resilient built environment.
Well, this is a good city to discuss resilience, because not everybody realizes that large parts of this country are actually below sea level. And when people in the UK say, what are we going to do about rising sea levels? I suggest you go and talk to Dutch engineers, because they've been keeping water out for the last 600 years, and they know something about it. Well, the next session on this stage will be at 11:20 with Nigel Coates. But for the moment, I'd like you to join me in thanking Andrew for what I think is just a fascinating insight into not only what the challenges are, but what the architectural opportunities are. And of course, it is true that architecture is essentially an optimistic business, because everything architects do is about the future, even when it's retrofitting history. Andrew, Whalley, thank you very much indeed.